Hello students and welcome to IP Study Lecture videos. In this video, we are going to cover chapter 11 of grade 8 and the name of the chapter is Understanding Quadrilaterals. Student, let us see what are the different topics we are going to cover under this chapter. So we'll see what are polygons and what are its different types. And then we'll see a special type of polygon which is called quadrilateral and what are their types. Then we'll see what is parallelogram and what are its special cases. Yes, so these all topics we have to understand under this chapter. So let's start with the first topic, polygon. Polygon is a closed shape made up of line segments. So any shape which is made up of line segment and is closed is called a polygon. Okay, so a polygon can be made of three sides because at least three sides are required to make a polygon. Otherwise, the polygon will not be, a figure will not be closed. Like if we use any two sides, then it will look like this. Okay, so to have a polygon, we need minimum three sides and the smallest polygon is triangle. So a flat surface like piece of paper is called plane surface. So before polygon, we have to understand what is plane surface, what is curve and how polygon get formed from there. So plane surface is any surface which is plane like this flat of piece of paper or there is no thickness. So a plane has no thickness and it just go in both direction, or we can say in any direction. So what is curve? So if we draw a figure without lifting our pen like this is called a curve. And if a curve is made up of line segment, then the curve is called polygon and it should be closed because curve can be open or closed depending upon what we draw. Okay, so there are two types of polygon. One is convex polygon and one is concave polygon. The polygon that have all diagonal inside the figure are known as convex polygon. So here basically we say if the diagonal lies inside the if all the diagonal lies inside the polygon itself, then it is convex polygon. But if one diagonal or more than one diagonal lies outside the polygon, then the figure or the polygon can be considered as a concave polygon. Now next is regular and irregular polygons. So I have told you that a polygon is made up of line segments. Now the line segment can be of same length or of different length. All line segment is of same length, then the polygon is called regular polygon, like in square, in case of four sides, or in case of equilateral triangle when we have three sides. Yes, so regular polygon will have all sides equal and all angles also equal, and these are the examples of non-regular polygon. Okay, now next is angle sum property of a polygon. Remember one thing, that every polygon has angles and the number of line segment is equals to the number of angles. Like for this we have 1 2 3 4 sides or 4 line segments, so it will have 4 angles, 1 2 3 and 4. So the sum of all interior angles of a polygon remain the same according to the number of sides regardless the shape of the polygon. So if we have polygon, then depending upon the number of sides, as I've told you, the number of angles will be there, and sum of interior angles, that is these angles, the sum of these angles will be given by the formula n minus 2 times 180 degree. So let's suppose if we have 5-sided polygon, then the sum of the interior angles will be 5 minus 2 times 180, which is 3 times 180 degree, which will be 540 degree. Yes, so the sum of 5 angles of a 5-sided polygon, which is also called pentagon, is 540 degree. Now we have some examples and their values given over here, you can go through them. Some of the measures of exterior angle of a polygon. So basically the interior angle changes with number of sides. The sum of interior angles changes with number of sides or number of angles, we can say. But in case of exterior angle, and what is exterior angle? So let's suppose if we have a polygon and if we extend a side in any one direction, then the angle formed by the another side and the line that we have extended is called the exterior angle. So if there are 4 sides, there are 4 interior, 4 exterior angles. If there are 3 sides in a polygon, then there are 3 interior angles and 3 exterior angles. Yes, so 4 exterior angles will look like this. If we extend here, it will be this. If we extend here, it will be this. But you have to remember that the sum of interior angle is same. That is, we have to find out using the formula n minus 2 times 180. So the formula remains same. But in case of exterior angle, the sum of the angles always a constant, which is 360 degree. So it doesn't matter what is the number of sides that you have, the sum of exterior angles will be always 360 degree. Now, if it is a regular polygon and have 3 sides, then each angle will be divided into 3 equal part and it will be 120 degrees. So you can say for an equilateral triangle, the sum of one exterior angle will be 120 degree. Yes, so this applies to irregular polygons. The sum will always remain the same whether it is a regular or irregular, small or large polygon. It doesn't matter. Either the side is greater or the size is smaller. It doesn't matter. The sum of the exterior angle will always be a constant, which is 360 degree. Yes. Now there is a question: find the number of sides of regular polygon if each exterior angle is 45 degree. So we know that 360 degree will be divided by number of angles and it will give us the measure of one exterior angle in a polygon. So in a regular polygon, if the exterior angle measures 45 degree, then to find n, we can just transpose them and we have 360 degree over 45 degree equals to n, and n will be 8 as your answer. So this is how you can find out values of exterior and interior angle if you are asked. Okay, so students, next topic is quadrilateral. A quadrilateral is a polygon made up of 4 line segment and there are 4 vertices that we can see. Let's suppose we have a polygon PQRS which is made up of 4 vertex or 4 vertices, I will say. So 4 vertices will form a polygon which we can call it a quadrilateral. Now it has some component or terms which we need to see. So these are vertices, opposite vertices, sides, opposite sides, angles, opposite angles, adjacent vertices or adjacent sides. So these are the terms that we quite often use while understanding quadrilaterals. So let's see one by one. So vertices are the points by which these quadrilaterals are made up of. These line segments which are connected by 2 vertices, or we can say 2 vertices are connected by a line segment, are called sides. The angles formed by these line segments at the vertex are the angles of the quadrilateral. Now these 2 vertex like S and Q are opposite vertex. R and P are called opposite vertex also. Also these are considered as opposite angles, like angle S and angle Q are opposite angles, angle P and angle R are opposite angles. Yes, and for sides also SR and QR are adjacent sides. QP and PS are adjacent sides because they share a common vertex. So if between 2 sides of a quadrilateral there is a common vertex, then those 2 sides will be adjacent sides. And opposite sides, so if S and Q are taken which doesn't have any common vertex, so these 2 angles are opposite angles. Yes, as R and P are opposite angles. Similarly S and R are opposite to P and Q side. So for opposite sides we need non-common vertex between them, and for adjacent side we need common vertex between them. Similarly for angle, we need if 2 angles are have to be adjacent, then they must share a common we can say side. Like for S and R are adjacent sides, adjacent angles, so they have a common side or common line segment. Yes, similarly for Q and P or PQ, we have we have a common side PQ, and these are termed as adjacent angles. So for opposite angles we need a non-common side. Yes, like P and we have R, so these are opposite angles. S and Q are opposite angles, and so on. So let's move to the next part, which is diagonals. So diagonals in a quadrilateral is a line joining 2 opposite vertex. Like if we have a quadrilateral ABCD, so when naming a quadrilateral we must follow a direction like either anti-clockwise or clockwise. If I write A here and B here, then C will be this. If I write A here and B here, C will be this and D will be this. So now if we join any 2 opposite vertex like A and C, B and D, then these 2 line segments or these 2 sides are the diagonal side, or we can say simply diagonal of the quadrilateral. So this is the one diagonal and this is the second diagonal. A quadrilateral has two diagonals. Clear? Interior and exterior of a quadrilateral. So if any point lies inside the quadrilateral, then that point is called the interior point of the quadrilateral. Yes, or we say that the point lies in the interior of the quadrilateral. Yes, and if it lies in the outside part of the quadrilateral, then we say the point lies in the exterior part of the quadrilateral. And if the point lie on the quadrilateral like this or this vertex, so these are called points on the quadrilateral itself. Yes, kinds of quadrilateral. So depending upon their property, a quadrilateral can be classified as trapezium, parallelogram, kite, etc. So a trapezium is a quadrilateral which at least one pair of opposite sides are parallel. So here we can say we have a trapezium where these two sides are parallel. So in a trapezium we have at least two opposite sides parallel. So we can have a trapezium like this also where these two are parallel. Yes, parallelogram, both opposite sides are parallel. For example, here CD will be parallel to AB and BC will be parallel to AD. Also, they are equal in length. That is, opposite sides are equal in length. That is, AB will be equals to CD and AD will be equals to BC. Kite. A kite is a quadrilateral which has two pair of equal adjacent sides and unequal opposite sides. So adjacent sides are equal like this, and opposite sides are unequal. Like these are equal and these two are opposite sides of the kite or quadrilateral. So this will be unequal. Yes, these two also be unequal. Now we have to deep dive into the topic of parallelogram. We'll see different type of parallelogram and what are the properties of parallelogram. So what are the properties of parallelogram? So there are certain properties that we need to look. Opposite sides are equal. The opposite sides are equal, as I have told you. Opposite angles are equal. So basically, basic definition of a parallelogram is the opposite sides should be parallel, and due to that property there are certain property that follows, like opposite sides are equal, opposite angles are equal, diagonals bisect each other. Like let's suppose if we have a quadrilateral like this and there is two diagonal like this, then this will be equals to this and this part will be equals to this. So both diagonal get divided into two equal parts. Now there are verification that we can go through. Verification of properties of parallelogram. I will explain you one of them and you can just go through other that have similar kind of explanation. So we know that a parallelogram is a quadrilateral in which opposite sides are parallel. Let's prove it in a parallelogram. Opposite sides are equal. Opposite angles are equal, as I have told you. Diagonals bisect each other. Angles, adjacent angles are supplementary. That is, if let's suppose if you are quadrilateral or parallelogram, then if we have a parallelogram ABCD, so adjacent angles like this and this, they have the sum as 180 degree. Yes, so let's prove one of the property, opposite sides are equal. So we need to prove that these two sides, that is this and this and this and this, are equal. Now we have a parallelogram PQRS where we have two diagonals also. So in parallelogram PQRS we have two triangles PQS. So if we say PQS, then this will be the triangle 1, because we need opposite sides. So this will be the first triangle and this will be the second triangle. So next is angle 1 is equals to angle 3. So this is angle 1 and this is angle 3. These two are equal. So to prove the properties of a parallelogram, the concept of congruency helps us. So here we have 1 is equals to 3 and 2 is equals to 4. These two are equal. Yes, these two pairs are equal, and we have a common side SQ. Now these two triangles are congruent to each other with the property of SAS. Yes, ASA. Say because two angle in one side, so ASA property will be there. And now if we try to see, these two sides are equal and these two sides are also equal, so we can say adjacent the opposite sides are equal in parallelogram. Yes, so you can go through all of the rest of the properties and you can find out how this all makeups. Yes, now moving to the next, let's suppose there is example 1. PQRS is a parallelogram in which angle P is this and angle Q is this. Find the measure of all angles of a parallelogram. So we have 5x plus 15 and 5x plus 15. Now These two are adjacent angles, and we know that we have a property of adjacent angles that their sum is 180 degree. So if we use this property, you will get x as 15 degree, and if you put over here, you will get that these two angles are 90 degree. Clear? Now moving to the next property, some special parallelogram. So there are some special parallelogram that have some special characteristics. One is rhombus, other will be square, and there is a rectangle also. Let's start with rhombus. A rhombus is a parallelogram in which any pair of adjacent side and opposite angles are equal. So in a parallelogram, all sides are opposite sides are equal. But if in a parallelogram, if all sides are equal to each other, then the figure or the parallelogram is called a rhombus. So in rhombus, we have opposite angles also equal, because we know that it is a parallelogram, so opposite angles will be also equal. Yes, so opposite sides of a rhombus are equal and adjacent sides are also equal. Opposite angles of a rhombus are equal. Yes, diagonals of a parallelogram bisect each other. So in a let's suppose we have a rhombus, then the diagonals will bisect each other because it is the property of parallelogram itself. Yes, adjacent angles are supplementary. So these are all the properties of parallelogram. So this will also be used in rhombus. Yes, diagonals of rhombus bisect each other at 90 degrees. So the diagonals intersect each other at 90 degrees. Clear? Now let's suppose we have to verify the properties of diagonal, that is it bisect each other to 90 degree angle. So let's have this using this rhombus PQRS. So here we have POQ, this one and this one. So here we can see how these two will be equal. So first this part will be equals to this because diagonal bisect each other. Yes, now this is also common, and adjacent sides will also be equal because all the sides are equal. So this using the property of SSS, you will have congruent triangles, which is we have ROQ and POQ and POS. Yes, now using this CPCT we can prove these two angles are equal and their sum is also 180 degree because it lies on a straight line. So the value of the angle will be 90 degree. Yes, which you can see over here. Now rectangle. So in a rectangle, each angle of the parallelogram become 90 degree, and the length of the diagonals are also equal. So if they will bisect, that is the case of parallelogram. So all the four parts that is formed using the bisection of two diagonals will also be equal because diagonals are all equal. Yes, so this will be equal to all four. Yes. Now there are certain properties. Opposite sides are equal. We know that in a rectangle opposite sides are equal because this is a parallelogram. Each angle is a right angle. Yes, in a rectangle it is a special property that if a parallelogram has each angle 90 degree, then it will be a rectangle. Diagonals are also equal, that I have told you. Diagonals bisect each other. So we know that diagonal bisect each other, but it would not be at right angle. Yes, it can be at any angle. Yes, so bisect each other. A square is a quadrilateral in which all sides are equal and each measure 90 degrees. So all sides become equal, which is 90 degree. Then the rhombus will become a square where all the property of rhombus as well as rectangle follows. Like the diagonals are equal in square, the diagonal bisect each other at 90 degree. So all the property of rhombus and rectangle are combined into square. Yes. So students, this is all from this chapter. I hope you have understood the chapter clearly and you are now able to solve the questions and prove the properties of parallelograms, and you have understood what are the different polygons and what are the different types of quadrilaterals, etc. What are the different components that we see over there. Yes, so we will see you in the next session. Till then, keep practicing, keep learning.